Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the transformations of cube root functions. Now, the most basic equation of the cube root function is f of x is equal to the cube root of x. Now, in order to make a table for this function, we want to plug numbers in for x that are perfect cubes. So my first number I'm going to plug in, I want to pick something that will fit on my grid here, is -8. And the cube root of -8 is -2. And on our graph, that would be this ordered pair right here. Okay. My next perfect cube would be -1, and the cube root of -1 is -1, so that would land right here. Then I'm going to try x equals 0, because the cube root of 0 is 0. And then I'll try cube root of 1, which is 1. That lands right here. And then I'll do cube root of 8, which is 2. Now, I could do more, but those are really the only critical points that are going to fit on my graph. So those are the ones we're going to use here. Now, we can move this function, this parent function, this basic function, around on our coordinate plane by using a transformation. So let's look at our transformation equation. You should be pretty familiar with this. F of x is equal to a times the cube root of b parenthesis x minus c plus d. Now, just like in previous function families you've studied, the variables on the outside of your function will affect the y values. So a and d only affect y. Likewise, b and c will only affect the x. Excuse me. B and c only affect the x. All right, so in example 1, describe how g of x and h of x are transformations of f of x equals the cube root of -x. So in problem A, we have g of x is equal to negative cube root of x. Now, because this negative is in front of our cube root, we know this is going to affect the y. So we're going to multiply each y by -1, which means you're basically just going to change the sign on it. So for example, our first ordered pair, -8, -2, would become -8, +2. So -8, +2 would fall right there. -8, +2. Oh, I forgot to put our critical points on this parent function here real quick. Hold on. I want you to be able to compare the parent function to the new function. Okay, so our original value was down here in the negative at -2. Our transform function is up here at +2. So on our second ordered pair, right here, oh, excuse me, I want that in blue, at -1, that would be -1, become -1, +1, which would land right here. Okay, 0, 0 would still be 0, 0. 1, 1 would become 1, -1. And 8, 2 would become 8, -2. So each point is reflected across the x-axis. Let me write that down for you. So for y equals negative f of x, you're going to reflect f of x across the x-axis. So let me kind of connect what this would look like. All right, in problem B, we have h of x equals the cube root of -x. So on this one, we're going to multiply each x by -1. Now, something kind of interesting is going to happen here. When we go back up to this first ordered pair and we multiply -8 by -1, we're going to get +8, -2. Now, here's what I want you to notice. We already have a point at +8, -2, right here. Okay. Now, if you take the next ordered pair, -1, -1, that would become +1, -1. And notice we already have a point right there. 0, 0 will stay there. And I think you can see what's going to happen on the pattern here. Now, why did this reflection across the y-axis, why is it the same graph? Well, you'll study this more in depth in later courses, but this is happening because the cube root of x is called an odd function. But I don't want to talk about that too much today. Just note that in this particular function, y equals negative f of x and y equals f of -x are going to have the same exact graph. So I want you over here. It's still, let's see, what did I do? Eraser. Let's see. We're still reflecting f of x across the y-axis. All right. Example 2. Describe how g of x and h of x are transformations of the cube root of x. So in problem A, we have g of x equals the cube root of x plus 2. Now, from previous lessons, you've learned that when you have the transformation y equals f of x plus d, we're going to shift each point up d units. So in problem A, your value of d is +2. So you're going to take each critical point. Let me label them here. We're going to shift each one of those points up 2 units. So 0, 0 will go up to 1, 1. Whoops, put that in the wrong place. So if this is my new 0, 0, my next critical point from there would be 1, 1, and then 8, 2. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So that branch is going to look like there, and then down 1 over 1, and then 1, 2, 3, 4, 5, 6, 7, 8, -2. So each point shifted up the y-axis 2 units. Each point shifted up the y-axis 2 units. Now in problem B, we have h of x equals the cube root of x minus 3. So in this problem, the value of d is -3. So we're going to be shifting each point down 3. So down 3, 2, 3, down 3, down 3, 1, 2, 3, down 3, 3. So it's going to look something like that. So each critical point on the parent function was just shifted down 3 units. So let's summarize that over here. Y equals f of x minus d will shift down d units. All right. Example 3. Describe how g of x and h of x are transformations of f of x equals the cube root of x. So in part A, we have g of x equals the cube root of x plus 2. So what I want you to notice is that this is inside the cube root. So that means this is the value of c. And remember, anything under the cube root will behave the opposite of how you think. So our c is -2, which means we are going to shift left 2 units. So left, each point will go left 2 units. So let me draw our critical points back on this parent function here so that we can move each one of them to the left 2. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So that's going to look something like this. So everything went to the left 2 units. All right. Let's summarize this over here. The shift for y equals f of x plus 3 is left c units. All right. In our next function, our c value is 3, so this will move, each point will move to the right 3. So I'm going to take my original points, 1, 2, 3, that goes off the grid a little bit, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So this is going to go something like this. Every point shifted to the right 3 units. So our horizontal shift, y equals f of x minus 3, is right c units. All right, example 4. Describe how g of x and h of x are transformations of f of x equals cube root of x. So in problem A, we have g of x equals 2 times the cube root of x. So noticing the 2 is outside the radical, that means we're going to multiply y by 2. So let me put my critical points on the graph. So if I take 0, 0, multiply it by 2, still going to get 0, 0. 1, 1, multiply that by 2, I would get 1, 2. That'd be right here. And then 8, 2 would become 8, 4. Over here, I'll do the same thing. Here and here. So to summarize this transformation, y equals a times f of x when a is greater than 1 will be a vertical stretch by a factor of, which I'll abbreviate BFO, by a factor of a. Vertical stretch by a factor of a. All right. Now in our next problem we have h of x is equal to 1/2 times the cube root of x. So this time we're going to multiply all the y values by 1/2. So we still have 0, 0. So 1, 1 would become 1, 1/2, and 8, 2 would become 8, 1. So that branch would go off that direction. Over here, this would be negative 1, negative 1/2, and negative 8, negative 2 would become negative 8, negative 1. So this branch would look something like that. So to summarize, y equals a times f of x, where a is between 0 and 1, will be a vertical compression by a factor of BFO a, whatever a is. All right, example 5. Describe how g of x and h of x are transformations of f of x equals the cube root of x. So in problem A, we have g of x equals the cube root of 2 times x. Now, I want you to notice that the 2 is now under the cube root. So when the number is under the cube root, it's going to behave the opposite of what you think. So we're going to be multiplying each x by the reciprocal of 2, which is 1/2. Okay, so let me put our critical points here so you can see them. So I'm multiplying my x values by 1/2. Okay, so 0, 0 would still be 0, 0. But 1, 1, let me write this down, 1, 1 would become 1/2, 1. So like right there, okay? And then 8, 2 would become 4, 2. that. And then the same thing would happen on the other side. Something like this. And then 1, 2, 3, 4, something like that. So, okay. So, do you see that your x values compressed? We went from 1 to 1/2, from 8 to 4. So, over here, when we summarize this, y equals f of bx, where b is greater than 1, this is a horizontal, and the reason it's horizontal is because we changed the x values. It's a horizontal compression by a factor of BFO 1 over B. It's always the reciprocal when you're talking about horizontal stretches and horizontal compressions. Okay, now I'm going to erase this red graph so you can see the next one. Okay, let me also erase these. All right, so in our next problem we have h of x equals the cube root of 1/2 x. So here we'll be multiplying x by the reciprocal, and the reciprocal of 1/2 is 2 over 1, or 2. All right, so 0, 0 would still be 0, 0, but 1, 1, if I multiply the x value by 2, would become 2, 1. So let me grab a red pen here. 1, 2, 2, 1. And then 8, 2 would become 16, 2. So that's going to be way off the grid. So we're not going to be able to really graph it, although we do know that it would kind of go on like that. And so this side would look something like this. All right. So to summarize this transformation, y equals f of bx, where b is between 0 and 1. Notice what's happening to your x values now. We're going from 1 to 2 and from 8 to 16. So we're stretching our x values out. So this is a horizontal stretch by a factor of BFO 1 over B. So whenever you have a number under your cube root, that means you're multiplying the x values by the reciprocal. This is the one that's a little tough for students to understand, but once you do, it gets much easier. All right. Now, in our last example, example 6, we're going to be matching each equation with the correct graph. Now, in a minute, I'm going to have you pause the video and try these on your own. But before you do, I want you to maybe, here is your original. In your original parent function, you have a coordinate point at 0, 0, 1, 1, and 8, 2. Let's just worry about the positive ones. So what I want you to do on your new graph is draw a point at your turning point. Okay, and this is going to help us see what's going on here. So here's my turning point. Okay. All right, so for instance, in graph A, if my original turning point was in 0, 0, you can see that we went left 2 and up 3. So I know my function would have to have cube root of x plus 2 because we went left 2. And then on the outside of the cube root, I'd have to have a plus 3. And so I can look at my list of functions there, and I see that that's the second one. F of x equals cube root of x plus 2 plus 3, letter A. All right. Pause the video and try the rest on your own. All right. Welcome back. Let's see how you did. All right. So let's see. In my first equation, I have the cube root of x minus 2. So that means I'm looking for a graph that moved down the y-axis by 2 units. And that was graph E. All right. In my third equation, we have cube root of x minus 2 plus 3. Notice this function goes to the right 2 and up 3. So 1, 2, and that was graph C. In our next function, we have cube root of x minus 1. So the only thing that function did was move to the right 1. So that would be D. All right, next one, f of x equals negative cube root of x plus 1 plus 2. So this should be a reflection, and it moves left 1 and up 2. Left 1 and up 2. So that would be graph F. And then on the next one, we have negative cube root of x minus 2 plus 1. So we have a reflection, and it moved right 2 and up 1. And that was graph B. Now, check your answers with mine. Fix anything that you got wrong. And that concludes today's lesson on transforming cube root functions.